Hello everyone, am I audible?
Yes, you're audible.
Sure, let's start. Uh, you can ask me if you have any problem in maxima and minima. Okay, in that case, we can start with integration. So, first of all, I would like to explain this term integration in the very layman terms. So, what is integration is like if you take a lot of infinite objects, let's say, okay, so I'll give you an example with the application of integration, like where do we use it? So let's say this is a graph, okay, and this is a function on the graph. Let's say this is the function y is equals to fx, right? Y is equals to fx. Okay. Now this function y is equals to fx is represented by this curve, right? And if I want to, let's say, find out its area between this portion, I want to find out the area under this curve from this portion to this portion. And before that also, I mean, this is a very genuine question and common sense. Like, how do people, have you heard about barter system? Anyone?
Yes.
Yeah. So barter system is basically an exchange, right? If you want, let's say me and somebody else have some commodity, for example, I have land and somebody else have, let's say, food, right? So what happened in the early 18th century, 19th century was not 18, 19, in fact, much before that. So what used to happen was people don't have units of measurement, right? We don't know about rupees. We didn't know about 1 meter square, 1 centimeter, 1 kilometer. These units were not defined. So we didn't know how to measure a piece of land, or let's say how to measure the value of any commodity or any object, right? So what people used to do was they used to barter. So they would exchange their goods with each other according to their definition of value of that particular product, right? But they won't have a certain value. Like if you have apples, you don't have a rate for that those apples. You will give someone apples, somebody will give you something else, maybe banana or maybe something else which you need, right? So that is how barter system used to happen. But now let's say I have a piece of land, let's say there are two people, A and B. Why do we need all of these things? So this is a short explanation on that. So let's say I have a person, there are two persons, A and B. A has one piece of land and B has another piece of land, right? And now these two are these two pieces of land don't look same, but they want to barter it because let's say her I mean it can be any reason, but they want to exchange it, right? So the problem is that which land is more. भाई ए बोल रहा है मेरे पास ज्यादा है, मैं तेरे को दे रहा हूँ, तो तू तो मेरे को कम दे रहा है वापस. The problem was this, ke we didn't have units of measurement in a lot of things, not just in land or not just in, I mean, we didn't even have currency most of the times, right? So both I mean, the things that we were looking for was how do we measure the value of a property or the value of a product, right? And in that one particular area is how do you find out the area of a portion. So this integration and other approaches were built to find out areas, to find out volumes of different figures. In fact, You know the formula for area of a square, right? You can also calculate area of a rectangle, area of a cone, area of a circle, but somebody did tell you the formula, right? Somebody invented that formula. And how did he invent that formula? How did he or she invent that formula? Using integration. So first of all, integration was designed by Newton. All the calculus, in fact, differentiation as well as integration. And Newton, we do not know Newton as a physicist. Newton was a mathematician originally, right? And he used a lot of concepts of calculus, in fact, developed a lots of concept. And after developing, he used those concepts in physics. So all the calculus, major proportion of calculus which you are studying right now is given by Newton. And all of these methods were devised to find out certain things. Most primarily in those times, they were used for areas and volumes of irregular shapes. First of all, regular shapes, then irregular shapes. So we can find out the area of this, but we cannot find out the area between this, because this is not a square or this is not a rectangle. This shape is curved, right? So how do we find out that? We use integration for that. Now let's understand the concept of integration. Integration money, in basic terms, integration money, summation. You're basically summing a lot of things. You are finding out the sum of infinite things, and you are making small things. You are adding small things to make a big thing. This is just a simple approach of integration. So what is differentiation? In differentiation, we used to break a big thing into small pieces. But if I talk about integration, here we build a big thing using some or various infinite things. So for example, I will give you an example, and that would make it more clear. For example, I want to find out the area under this portion, right? Let's say this is x is equals to a and this is x is equals to b. I want to find out the area under y is equals to fx curve, which is this, from x is equals to a to x is equals to b. So basically, I want this area, the shaded portion. Now, how do I do that? I don't have any formula because this is not a regular shape, first of all. So what we can do is, we try to interpret this thing as this. Let's make infinite strips. This is a strip. This is again a strip. This is 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 a strip. I'm making this infinite small strips, and I will, if I can find out the area of one strip, then I can add all of these strips to find out the area of whole portion. This is the simple concept of integration. So integration is summation, adding small things, adding small units to form a bigger unit, adding small units to form a bigger unit. Right? So this is how we can find out the area of this curve. Now, can you tell me what is the area? Okay. So first of all, this is this strip. Let's talk about the first strip. This strip, right? So this strip, why did we make such a thin strip? First of all, because this thin strip can be taken as a rectangle. आप सोचो कि ये छोटा सा strip एक rectangle की तरह है. ऐसी I have a lot of rectangles. If I can find out the area of one rectangle, then I will add each rectangle to get the whole area. This is my intuition, or this is my logic that integration is following, right? Now, if I want to find out this area, this would be length into breadth. If I consider this a rectangle, now what will be the height? Height we know, but what would be this? I mean, what's the width? Width is very small. If you see, width is very small, and this very small width and this very small width, right? Okay, so what is this? What is this point? If this is x is equals to a, then this should be fa. If you observe this point, fa mane the value of y at x is equals to a, right? So this whole height is basically represented by your y, right? So area. Okay, remember this. Okay, we're going to use this concept in the next chapter again. because this is the main application of integration which you will be studying. So we will be studying integration to find out the area under curves in the next chapter, 8th chapter, and then 9th chapter we will be using the same integration for solving differential equations, right? That is a totally different concept that we will talk about that later on. But area is a very related concept. Is a very, I mean, the first thing you should know about integration is what should it do? Why did we start it? We started it because we wanted to find out area. The main application in your syllabus to find out, of integration or integral calculus is to find out area. Right? Now, how can we find out area? Area would be if I integrate. So this is a sign of integration. Or we read it as integrate. Integrate. Okay. So first of all, what's the area of a rectangle? Area of a rectangle is height into width or length into breadth. Height is or length is y. And this width is dx. Dx is basically a small change in x. If I integrate it from a to b, what's the meaning of this? I will tell you later on. These are a and b. This is integrate. This a and b, limits of integration. But this particular expression represents area under curve fx, area under curve y is equals to fx from x is equals to a to x is equals to b. Now, again, come again. Let's write another expression. Area is equals to y into dx. Now, I'm not using the limits. Okay, I'm not using the limits. Now, what does it represent? This also represents the area under curve y is equals to fx, but this includes the area from wherever the curve is starting up to the wherever the curve is ending. So this is not just this area. This shaded portion is represented by this. So if I take limits of an integration, it means that I want to find out area of a certain portion. Or rather than that, you can also see it like this, that if I'm putting a limit on integration, it means that I am not observing the whole thing. I am just taking a piece out of the whole thing, and I'm observing that piece. Right? So wherever this is the lower limit and this is upper limit. So b is upper limit of integration, a is lower limit of integration. So wherever the lower limit is, you will start your observation from that and you will go up to b, the upper limit, right? So this means, and this limits is the values of x, by the way. Whatever your dx is, that will reflect in your limits. I mean, whatever you use the variable here in d of, if you write d of y, then the values a and b will be for y. If you're writing dx, then it means the values are for b and a. So these are some basic things. First of all, क्या करते हैं हम इंटीग्रेशन से? एरिया निकालते हैं. सबसे मोस्ट पॉपुलर यूज तो एरिया निकालना है. आई एम नॉट जस्ट सेइंग के वी ओनली फाइंड आउट एरिया यूजिंग इंटीग्रेशन. वी डू अ लॉट ऑफ थिंग्स यूजिंग इंटीग्रेशन. We do a lot of things. I mean, believe me, when you go in engineering, you won't have anything other than integration, differentiation, and matrices. All the topics are from these three. And your complex number again, which you studied in class 11th. These 4 topics, very important and can be extended to a lot. I mean, they can be taught in depth because they have a lot of application. Lots of application. राइट? तो बहुत ही सिंपल चीज. कोई पूछता है इंटीग्रेशन क्या करता है, यार एरिया निकालता है. अगर लिमिट्स के साथ दिया हुआ है तो एक पर्टिकुलर पोर्शन का एरिया निकालेगा. अगर विदाउट लिमिट्स दिया हुआ है तो पूरे कर्व के अंदर जितना भी एरिया होगा वो निकालेगा. राइट? If limits are applied, then we are only considering a small portion, starting from the lower limit and going up to upper limit. But if we are not using the limits, it means that we want to find out the area, whole area under this curve. Now, however big this curve is, that is good. I mean, you have to find out all the area. Correct? This is the basic explanation of integration. Now, this is just for your understanding part. This won't help you much in क्वेश्चन सॉल्व करने में. ये तो बस तुम्हें समझना है कि क्या कर रहे हैं हम, क्यों कर रहे हैं यार, इसलिए कर रहे थे यार. मेन काम तो ये था. जब शुरू किया था तब तो मेन काम यही था. आज तो बहुत सारे काम है हमारे पास, बट when we first found it, when we first invented it, the main use of this was to find out area and volumes. ठीक है. Now let's start. What is integration? And okay, chalo, interpret. We do know how to interpret integration. We are finding out some area, right? This is one application. Now let's talk about mathematical terms. What is integration? How do we find out, how do we integrate a function? So when we say integration, it means that we are integrating a function with respect to some variable, right? And also I would like to tell you two more things here. So when limits are not used, this is called indefinite integration. This is not definite. You can easily observe this. I mean, this is very intuitive, that if there is no limit, then it's indefinite. There is no bound. No bound. It's not restricted. It's indefinite, right? So it is indefinite integration when limits are not used. And when your limits are used, it's called definite integration. Definite integration and indefinite integration, right? This is the basic thing, first of all. Okay, so what are we starting with? We will start with indefinite integration first, and this will be our main topic for first 4-5 classes, at least 4-5 classes. It may also increase, but at least for 4-5 classes, we will be studying first indefinite integration. Also, this is the bigger portion in the integration. So integration will be divided into two parts. First, we will cover indefinite integration, which will include around 7 exercises of your NCERT. And then we will cover definite integration, which will include around 3 or 4 exercises of your NCERT, right? So let's start with indefinite integration, and also let's connect integration with differentiation. Just give me a minute. Yeah. Okay, so we'll start with different integration. I would also like to add one more point here. Because we have two major issues. One is The first question is this: how to find out area when a function or curve is given, right? It can have irregular shapes that can be solved using integration, right? Integration will definitely answer that, and definite integration will answer that, by the way, because most of the times when you will be finding out area, you will be given the coordinates from where to where find out area, and you will find that out. So definite integration is the answer for this question. And the second question would be, okay, second question, I would also like to tell you this question. Okay, so we have a function, let's say fx, right? Now I can certainly derivative, I mean, I can certainly differentiate this function. It will produce f dash x. So from fx to f dash x, I can reach via differentiation. But if I know f dash x, can I find out the original function? That is also, I mean, that is equally important as to find out f dash x from fx. If you have reached from fx to f dash x via differentiation, then how would you reach from f dash x to fx? The answer is, again, integration. That is why they are related to each other. That is how they are related to each other, actually. Where, Chavez? No, we are not going to multiply dx anywhere right now. So the second question is, if we have f dash x, by the way, this particular application is the next chapter, actually, area under curves. I will write it in a minute. So if we have f dash x, can we find fx? Answer is again yes, using indefinite integration. Yes, using indefinite integration. So these are two forms of integration, which is made by answering the specific questions. My bad, yaar. Actually, my placement process is going on, so बहुत ही hectic हो रखा है अभी थोड़ा schedule. Sorry. Yeah. So these two specific questions were answered using two different techniques of integration. One is definite and one. We will discuss about them in detail. But now, by the way, if we are reaching f dash x from either via differentiation, then from f dash x to fx, we can reach through integration. This is why you can easily see this. See, this is why the integration is said to be inverse process of differentiation. Via differentiation, you break your bigger function fx into smaller functions f dash x. F dash x is a smaller function. Okay. You can go through this. I have x cube and I want to differentiate it. The differentiation would be 3x square, right? So what are we doing? We are reducing the power of x. छोटा ही बना रहे हैं ना फंक्शन को, जबकि इंटीग्रेशन में बड़ा बनाएंगे. इंटीग्रेशन में x स्क्वायर का x क्यूब हो जाएगा. So integration will change x square to x cube. It will increase the powers, but differentiation will decrease the power. That is why I have repeatedly said that differentiation will break your function into smaller parts, and integration will add all the small parts to make a bigger part, right? Okay, now let's come to the pure mathematics of integration. How do we solve it? भाई ये सब तो ठीक है जी, चलो समझ गए. अभी मेरे को ये बताओ कि करना कैसे सॉल्व, क्योंकि सबसे ज्यादा प्रॉब्लम तो दोस्त वहीं पे होने वाली है. Questions. So I will tell you a case. What happens in integration is, let's say you are solving differentiation, right? You will have something to do in differentiation. You may not be able to solve the whole question. I get it. You may not be able to solve, but you do know some steps. You may make a mistake in calculations, or you may not get the last part, but you will certainly do something in differentiation. ऐसा नहीं होगा कि बिल्कुल खाली बैठे हमें समझ ही नहीं आया करना क्या है. इंटीग्रेशन में बिल्कुल ऐसा ही होगा भाई. Integration will be के we are not even able to think how should we approach, what should be the first step, what should I do if you give me this question. This is the main problem with integration, because it is heavily dependent. And why is that problem? Listen to, it is heavily dependent on formulae part, on formulae and intuition. Now intuition will develop if you practice a lot, and formulae will develop either you write all of these formulae in a center page, like I would tell you to do so, but you guys won't do this, right? You haven't done this even in trigonometry. So if you won't do this, so there will be a problem. I may not be able to complete the question, because I will say all, I mean, what would I do? I would solve 20 question, 30 question initially on a particular topic. Then what will I do? I will expect you guys to learn formulae. And if you're not learning the formulae, we may not be able to reach the final answer. And that will create problems later on. So इसलिए I would suggest all of you to write all the formulae in a center page. There will be a lot of formulae in this chapter, around 40 to 50 minimum. So please, everybody, write all of these formulae on a center page. You will not be even able to remember them, first of all. भूलना तो बाद की बात है, पहले याद ही नहीं कर पाओगे. पहले तो याद करो सारे. याद करने के लिए प्रैक्टिस लगेगी, सेंटर पेज लगेगा, क्लास में आके क्वेश्चंस करने पड़ेंगे, पेन चलाना पड़ेगा. पेन नहीं चलाया तो कुछ मिलना ही नहीं है इधर. अगर if you are not using your pen extensively over the next 10 to 15 classes, you won't be able to get something out of this chapter, believe me. Okay, so please use your pen and use your mind wisely. Solve करने होंगे question. All I am trying to say is this. Okay, yeah, so let's start with indefinite integration. So how would I like to define this? An inverse process to integration, to differentiation. An inverse process to differentiation, right? Now let's understand this. So it means I will try to explain. Let's say if I am differentiating sin x, can you tell me what is the differentiation of sin x?
Cos x.
Cos x. It means now we have started with the maths of integration. Please focus on the class now. If you are not, if you haven't, it's okay. कोई बात नहीं, सारा ज्ञान था, फालतू का ज्ञान था. मतलब फालतू का नहीं था. अगर आपको इंटरेस्ट है तो अच्छा था, नहीं है तो कोई दिक्कत नहीं. पर अब भैया अगर इंटरेस्ट है या नहीं है इससे मतलब नहीं. अभी ये बात समझनी पड़ेगी जो मैं समझा रहा हूँ सारी. इज यू हैव टू फोकस ऑन दिस. इफ यू आर नॉट एबल टू focus here, so please tell me. I'll restart. Every time I'll explain myself. You just have to ask. Okay. Now, Faiza, we are about to discuss what is indefinite integration. So first of all, it is an inverse process to differentiation. Now, what does that mean? What does this sentence mean? You can understand it using this example. So let's say I am differentiating sin x. It means that I am finding out derivative of sin x with respect to dx, which I know is cos x. Correct? It means that if I integrate cos x, then I will get sin x. Come again, come again. What is the differentiation of x square? Can anybody tell me?
2x.
2x. Which means that if you integrate 2x, then what should be the answer? This is the integration of 2x. This is the integration of cos x. This is the sign of integration. And we will integrate with a variable, preferably with the variable that we have here. So basically, right now, we are integrating cos x with respect to dx. Similarly, in the second case, we are integrating 2x with respect to dx. Integration, the answer would be, output will be x square. As I said, inverse process to differentiation. तो अगर sin x का डिफरेंशिएशन cos x है, इस बात का मतलब यह है कि cos x का इंटीग्रेशन sin x हुआ होगा. If you are saying differentiation of x square is 2x, it means that differentiation of 2x, sorry, integration of 2x is x square. Is it clear to everyone? Good, very good. Can you tell me the integration of sin x? Try to think about it. If you want to find out the integration of sin x, you need sin x here. यानी कि you need that function first, whose differentiation is sin x. I wanted to find out the integration of cos x. तो पहले मैंने ऐसा फंक्शन ढूंढा जिसका डिफरेंशिएशन cos x है, क्योंकि cos x का इंटीग्रेशन फिर वो फंक्शन हो जाएगा. करेक्ट? The differentiation of sin x was cos x. That is why the integration of cos x is sin x. Now, my same question is, can you tell me the integration of sin x now? Okay, what's the differentiation of cos x?
Minus sin x.
Minus sin x, correct? So can I say, Kharif, that integration of minus sin x would be cos x?
Yes, sir.
Correct, right? But what do I want? I want the integration of sin x. Rather than minus sin x, what I need is sin x. So can I multiply negative on both sides? If I
Yes,
multiply with negative on both sides, this becomes positive. What does that mean? That the differentiation of minus cos x is sin x, which means, correct, Faiza, very good. Which means that the integration of sin x would be minus cos x. सारे फॉर्मूले ऐसे ही बना लेंगे हम लोग. We will create every formula using the same rule. Because the rule is very important. The rule is telling you how to integrate. This is the whole rule. भाई यही है rule. ये rule होना चाहिए. The basic approach, the approach that we should follow is, if I want to integrate cos x, it basically means that I want a function whose differentiation is cos x. Correct. Good. Chalo. Now, one more thing. There's a problem here. चलो अभी जरा प्रॉब्लम भी देख लो यार छोटी सी. There is a problem here, certainly. I don't know whether you guys, I mean, I know that you haven't thought about this, but let's try this. Okay, let's come again. Let's come again on this example. Okay, we know that the derivative of sin x is what? Cos x, correct? Which means that integration of cos x should be what? Correct? Now, what is the differentiation of sin x plus 4?
cos x.
If we are adding 4, then 3, does that change our answer?
No.
No, right? And I could have subtracted as well. right? If I would have subtracted -10, then that would also not change the answer output. Correct?
Yes.
Yeah, Shavis. Correct. So sin x plus 4, or rather than sin x plus 4, if I can even use any constant here. I could have added something, I could have subtracted something, and the answer would have been cos x only. Now, अभी तो भाई बोल के आए थे कि रिवर्स प्रोसेस, तो रिवर्स प्रोसेस है तो यार ये इंटीग्रेशन ऑफ cos x दिस टाइम शुड बी sin x plus 4. हाँ 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 हाँ, क्या कर रहे हो सर? क्या बता के रहे हो? गलत बात है। मैं पहले कभी कहते हो cos x का इंटीग्रेशन sin x है, कभी कहते हो cos x का इंटीग्रेशन sin x plus 4 है. व्हाट्स द रियल आंसर? The problem here is the problem that I want to highlight here is the same. You can have a multiple expression as long as this k is constant and you are adding or subtracting some constant, right? You're adding or subtracting some constant, then answer would be cos x. So what is the integration? What is the actual integration of cos x? The actual integration, while writing actual integration of cos x, what do is we put a c. What is c? Constant of integration. What is c? Constant of integration. What does it do? Defines the family of curve, or represents, rather I should write it like this. Represent the family of curves. Represent the family of curves. Now, what does this mean? Here, family of curves mean if you draw the graph of sin x, let's understand this graphically very quickly. So if you draw the graph of sin x, this is this, right? And if you draw the graph of sin x plus 4, the same graph will be upscaled here. Same graph, the graph will be above. So this is sin x plus 4, and this is sin x. This is sin x plus 4, and this is sin x. These curves are same. They are known as family of curves. In this case, family of curves. Family of curves means curves same hai. All the curves are same. They are just stacked onto each other. Either one will be up, one will be down. ऐसे कुछ हो रहा होगा बस. Family of curves, same curve has been shifted either upwards or downwards or rightwards or leftwards. Same family of curves. So C is used so that we know that if we add any constant in sin x, that won't change the answer of differentiation. That is why while integrating cos x, and because we are doing indefinite integration, again, if you would have limits here na, a to b, अगर हमारे पास यहाँ पे limits होते तो आंसर कुछ अलग आता. This would not be the answer. Answer would be a constant in that case. But if we don't have limits, we will always use C, constant of integration. This also tells you that the integration is indefinite. So it is an indicator of indefinite integration. Indicator of indefinite integration. Indicator of indefinite integration. Right? That is why we are using this C. Is it clear to everyone? Why did we use C? Sin x के साथ कुछ भी ऐड या सब्ट्रैक्ट करेंगे कांस्टेंट में कोई फर्क ही नहीं पड़ेगा यार. आंसर cos x ही आता रहेगा. तो जब मैं cos x को इंटीग्रेट कर रहा हूं तो सिर्फ sin x नहीं दे सकता. सिर्फ sin x नहीं दे सकता, sin x के साथ कांस्टेंट ऐड करके दूंगा, क्योंकि अगर कोई कांस्टेंट ऐड भी हो रहा होता तब भी आंसर sin x का डिफरेंशिएशन cos x ही आता। तो every time you perform indefinite integration, you always use this c. हाँ जी, we are good to go. ठीक है, बस I just wanted to tell you this small thing. Now the main task is to approach towards, first of all, basic formulae, very basic formulae, which, so whatever formulae you have studied in differentiation, everyone will be used again. Okay, let's start with the basic formulae of integration, and that will be derived from all the different expressions that we have used in derivatives. So we will try to cover the basic integration first of all using differentiation only. By the way, guys, everybody has NCERT right now? If not, then you can raise your hand. And if yes, please come to page number 289. Book 2, 289.
I have only book one, not book.
Tarif, you can find that out on Google. Please download this from the Google. Write indefinite integration class 12th NCERT, and you will get the PDF. Fatafat, quickly download the PDF. And everybody who has integration, I mean, who has book, come to page 289. And there is a table given on this page. I just want to tell you the meaning of everything. I mean, you should know this. 289, page 289. Table 7.1. So first is integration of fx dx. The meaning is integral of f with respect to x. There is a function fx which we are trying to integrate with respect to dx. Now, this function fx is known as integrand. Basically, the function which is to be integrated. X is called variable of integration, right? And constant of integration will be represented by c, and this is considered as a constant value because, and I have told you the explanation why did we use this constant value, right? Sure, then but just wanted to tell you the small meanings of these and integrand, about the integrand and variable of integration. We can also write it here if you want. So we are basically trying to find out a function, capital function fx, which we obtained after integrating fx dx, right? So this x is variable of integration, and this fx will be integrand. Integrand means the function which needs to be integrated. And this capital fx is the integrated function, the final output, right? Sure. So let's start with basic formulae of integration, which we will try to formulate from derivatives only. So first is, let's start with first. So we do know that differentiation of a constant. Differentiation of a constant is anyone?
0.
0. So integration of 0 should be
Okay.
constant, some constant, right? So if we are trying to integrate there would be another constant only, Chavez. Can't say really 0. It can be 0 as well. Think with the just think with the logics. You will get everything, I'm sure. Just think with the logic. तो अगर 5 का डिफरेंशिएशन करता हूं तो 0 आता है, तो 0 को इंटीग्रेशन करने पे कोई कांस्टेंट ही मिलेगा, दैट इज श्योर. I'll get a constant, but what value? I'm not sure about that. That can be used with certain methods. That can be find out using certain methods, but we don't need to find that out right now. We will use this concept in chapter 9. वहां पे हमें constant of integration की values भी find out करनी पड़ेंगी, but that is a different topic. That is a topic for later on. So right now we can, okay. So this, I mean, this is not a formula. I'm just trying to recall the, or I'm trying all of you to recall all the formulae from derivative. Okay. Second was, what is the differentiation of x to the power n? What is the differentiation of x to the power n?
nx raised to n minus 1.
Nx raised to the power n minus 1. Correct. Correct. Okay. Good. Can you also differentiate this? Power is n plus 1. I mean, x to the power 7. How do you differentiate x to the power
n
7?
plus 1x into n plus 1 minus 1.
N plus 1 into x to the whole power 1. You can subtract one power, right? Which should be what?
Yes.
Which should be what? If you subtract one power from n plus 1, it becomes m, right? So the differentiation of x to the power n plus 1 is n plus 1 x to the power n. Now, what do I need to find out? I want to find out the integration of x to the power n. If I have a function which is polynomial, how do I integrate that? Simple. Use this. Take this n plus 1 into the left hand side. What does this become? Always use c. Never forget c in indefinite integration. The final answer will always include c, constant of integration. Now, there is just a little math that may confuse you later on. Let's say we had a constant here k. मान लो यहाँ पे कोई constant भी था, ठीक है? Then what would be the answer? Same, right? If you take n plus 1 to the left hand side now, this becomes x to the power n plus 1 upon n plus 1. So if you take this, this can also be written as, if you take n plus 1 from the right hand side to the left hand side, then it can be written like this. Right? And that will lead us to a confusion that why are we not writing this k upon n plus 1? Why are we only writing it as c? Because k is also a constant and n is also a constant. This value in itself is a constant. We don't know what is this value, but the whole value is a constant only. So instead of using k upon n plus 1, we are just writing c as a constant. Because ये भी तो कोई constant ही है ना? If you solve k upon n plus 1, that would be a constant value. Because you know k, you know n. Both of the values are known. So whatever this k upon n plus 1 is, that would also be a constant. That is why we are writing it like this. So the first formula is how to integrate polynomials. So differentiation में हम क्या करते थे? We used to reduce the powers, but in integration we increase the power, right? And whatever is the power, we divide the whole expression by that power. So I'll also try to use, or I'll also try to perform an example with every set. So let's say I have this function x cube and I want to integrate it, then I would write it as x to the power 4. I will increase the power, and whatever is the power, I will divide the expression by that power. We'll add c. Come on, once more. What would be the different integration? x to the power 11. Quickly, don't write. Please speak up. Don't write. Plus c as well, Pfizer. The answer is correct, but don't forget c.
X raised to 12 by 12.
Correct. ठीक है, एक और कर दो फिर. Root x. Root x is as important as. What was the differentiation of root x, by the way? कोई भी एक, सबसे पहले मेरे को ये बताओ. What was the differentiation of root x?
1 by 2 root x.
1 by 2 root x. Now, what is the integration of root x? We know that the integration of root x can be written as x to the power half. But I will write it as root x only. Root x is nothing but x to the power half. हाँ जी, क्या है आंसर बताओ.
2x raised to 3 by 2 by 3.
Plus c. Don't forget c. Please. Quickly. Correct, Faisal. हाँ जी बताओ. Very good, Faisal. Very good. भाई एक पावर बढ़ाने का है. Increase the power by 1 and divide with the same power. So x to the power minus 4 would be x to the power minus 3 divided by minus 3 plus c. Okay, one last question. Anyone? X to the power. Faiza, I got your answer. I'll tell you. It's incorrect, but I'll tell you why. I'll give you a logic and you tell me whether that reasoning is wrong or right. Okay. Shav is correct. Good. Okay, so the logic explains that x to the power minus 1 should be x to the power minus 1 plus 1. We have to add a power. So it becomes. The problem is, Faiza, that you have not accounted this 0 in the denominator. Why? भाई पावर 0 होगी ना, तो x to the power 0 तो 1 बनेगा, बट नीचे वाला 0 कहाँ जाएगा? उसको भी तो काउंटर कर. उसका क्या करें? तो which means ये तो बिल्कुल नहीं करना, और this is avoidable situation in maths. We would never make denominator 0. We have already talked about it, right? So this formula fails here. Now, please write here, not valid for n equals to minus 1. This is not valid for n is equals to minus 1. If n is minus 1, then there is a different route that we have to follow. And why is that? Why is that? Because you know, bhai, what are you doing? You are trying to integrate 1 upon x. So you basically need to find out a function whose differentiation is 1 upon x. Then you can say that the integration of 1 upon x is that function. Do you know a function whose differentiation is 1 upon x?
Minus 1 by x square.
Minus 1 by x square. Its differentiation is 1 by x. Oh. तारीफ ये इधर नहीं होता, मेरे वाली मैथ्स की बुक में नहीं होता ये. तेरे वाली थोड़ी अलग है. कोई तो बताओ, what is the differentiation of, I mean, tell me a function
Log
whose
x.
differentiation is 1 by x. Yeah, correct, log x. No, Faiza, log x का differentiation 1 by x होता है. x का differentiation तो 1 होगा ना, right? So if you are trying to integrate x to the power -1 or 1 upon x, then its integration would be log x. And why it's not valid, you got that point, because it is not valid because the denominator is 0. So we would avoid this. ये तो हम चाहते ही नहीं कभी भी यार. We would not want to make our denominator as 0. So what should be the approach? Approach should be, bhaiya, tell the new formula. What? Differentiation of ln x was 1 by x, which means that integration of 1 by x would be what? Ln x plus c. Because there was a formula already, that is why we will use that formula. Correct? Shallow. Now we do know the differentiation of sin x, which is cos x, which means that we also know the integration of cos x, which is sin x plus c. Bhai, please ye sare formula, please note down all of these formulae on a center page. Please take that center page with you for the next 1.5 months. You will be needing these formulae again and again, and I would not like to express myself repetitively again on this same topic, that please write all these formulae and remember them. I expect you guys not to remember them overnight, but I do not expect you guys to not write them and not, I mean, I don't expect you to be dumb. I can expect you to be innocent or naive, but I can't expect you to be dumb, right? So that is what I'm telling कि लिख लो. मेरे को पता है याद नहीं होंगे, मुझे खुद ही पता है, मैं बोल रहा हूँ याद नहीं होंगे, तो इसलिए लिख लो. नहीं लिखोगे और फिर आंसर भी नहीं दोगे तो वो प्रॉब्लम है यार, फिर वहां पे मैं पकड़ लूंगा, वो मेरे को, उससे मेरे को थोड़ी प्रॉब्लम होगी. ओके, सेम लॉजिक गाइस. cos x का माइनस sin x होता है. The differentiation of cos x is minus sin x, which means that differentiation of minus cos x is sin x. That is why this. Then again, what was the differentiation of tan x? Anyone?
Sec square x.
Sec square x.
Sec square x, correct. So sec square x was the differentiation of tan x, which means that if you integrate sec square x, it would be tan x plus c. Anji, next, what is the differentiation of sec x?
Minus cosec x cot x.
Sec x कहाँ होता है भाई शावेज? ये माइनस कोसेक एक्स कॉट एक्स इधर कौन सी गली में है ये बता दे पहले. इधर मेरठ वेरठ वाली साइड यूपी में नहीं चल रहा यार, ये गलत पढ़ाया शायद हमने. बोलता हूँ मैं, बोलता हूँ, कराता हूँ सही. सेक एक्स का डिफरेंशिएशन माइनस कोसेक एक्स कॉट एक्स कराते हैं. So differentiation of sec x is sec x tan x, which means that integration of sec x tan x is sec x. हाँ जी, differentiation of cosec x. This is minus cosec x cot x, right? So we can say that the integration of cosec x cot x would be minus cosec x. Just multiply both the things with minus. And cot x would be minus cosec square x, which means that if you integrate cosec square x, then what will you get? you will get, sorry, my bad. You will get minus cot x. Correct? Okay. We do know the differentiation of inverse function also. What is the differentiation of sine inverse x? Anyone?
1 by root of 1 minus x square.
1 by root over 1 minus x square, which means that if you try to integrate an expression like this, the answer would be sine inverse x. भैया इंपॉर्टेंट है ये सारे फॉर्मूले, ये तो काफी इंपॉर्टेंट है, और 9th वाला जो भी लिखा गया है, 9th 10th 11th will be very important, but all of these are formula are very important. Every formula is very important. I would not like to reiterate this fact again and again, because this is the first class. I would tell you everything today. I mean, I will try to. Chavez, just give me a minute. This would become 1 upon 1 plus x square dx would be tan inverse x. यार अभी तक तो सिर्फ we have talked about the basic application, that if we know the formula of derivative, we do know 9th and 10th are basically same. If you remember, then sine inverse x plus cos inverse x was pi by 2. The sum of sine inverse x plus cos inverse x was pi by 2. So you can write cos inverse x as constant minus sine inverse x. A constant minus sine inverse x. So these two formulae are not different, 9th and 10th. Both are same. Is that okay, Shavis? Or do we need to go up? Cool. Shavis, is it done? We do know the differentiation of e to the power x. It was e to the power x, thankfully. That is why the integration of e to the power x is also e to the power x. So e to the power x was e to the power x. That is why integration of e to the power x is e to the power x. So e to the power x differentiation and integration both are same. Now a to the power x. A to the power x is a to the power x log a. It means that if you integrate a to the power x, take this log a to the left hand side, it becomes a to the power x divided by log a plus c. Obviously, the base would be e. So these are some basic formulae. We can apply them easily, right? Please try to remember all of these formulae, and also along with this, everybody, along with this, also remember the trigonometry formulae, because in the next class we will try to cover 2 exercises, not 1. Remember all, try to revise all of these formulae as well as formulae from trigonometry. We will continue this class tomorrow. Okay. So we will continue the class tomorrow now, and please try to just remember all of these formulae. एक बार रिवाइज करके आना है ना सभी लोग. Tomorrow we will try to complete 2 exercises. Chalo, okay. Bye bye, guys. Okay.